In step 4, we are ready to formulate our decision rule. And really what this means is that we're going to describe the situation under which we would have enough evidence to reject the null hypothesis. So again, we're really drawing upon what we've done in steps 1 through 3 to outline what it will take in step 5 for us to reject the null hypothesis. So in step 3, or let's focus on our chopstick example here. So in step 3, we decided we needed the z statistic, right? In the blue here in the chopsticks, we knew the population standard deviation, and so we're working with the z statistic. We also know that we're dealing with a two-sided test, and we know that because the hypotheses are set up in a way that indicates a two-sided test. So our null hypothesis is saying that the average length of our chopsticks is 10 centimeters, or really, it's not wildly different than 10 centimeters. And our alternative means that it is not 10 centimeters. And so we are interested in evidence in either direction. So if they're too short, that would reject the null, and if they're too long, that would also reject the null. So we're working with a two-sided scenario, and so we can think about the normal distribution and really incorporating both sides. That might be confusing there. Let's stick with the blue. And so we are interested in, or we're curious about, if the evidence will show up on the extremes in either side. Now again, to highlight the difference here, the red scenario is going to be a one-sided test where we're only going to learn or reject the null if we find evidence of a mean much less than 52,000. So those things we need to take into account when we formulate our decision rule. And at this point, we're going to, in some sense, you can think about it, setting up what z-score is going to be sufficient to reject the null. So when the z-score again is going to be pretty straightforward, right? So if we and I believe, and maybe this is different from past videos, but we had been talking about a 95 or I switched back, about a alpha of 0.05. Okay, so let's combine steps 1, where we have the null and alternative, step 2, where we've decided on our level of significance, and step 3, the z-score, or the z statistic. And we're going to combine all of that into determining where these critical values are. And we often will refer to them as the critical value. Should be helpful if I put it where you can read it. Critical value. Okay, and really there's kind of two critical values here, but they're going to be mirrors of each other. Now, the critical value is going to be, in our case here, the z value for which we would reject the null. And again, familiar, this will feel familiar, the z value here is going to be 1.96. Right? So if we find a z value of 1.96 or negative 1.96, and really it's if we find that or greater, if we find 1.96 or greater anywhere over in this region, we will reject the null, and similarly anything below negative 1.96 we would reject the null, and that is why we also refer to these as the rejection regions. Okay, and similarly on the other side. And so now we are primed and ready to calculate our z value in step 5, and to know right away whether or not that z value is sufficient to reject the null. Now again, in our red scenario down here, because we're working with a one-sided test, since we're working with a t-statistic, the process is a little bit different. We're going to need to know our sample size, and we're going to need to incorporate that as we develop our critical values, or in this case, a single critical value. So let's take, for instance, we're going to say that we're taking a sample size of 25 individuals in the community. Of course, then so let's say n is going to be 25. Then we know again that degrees of freedom is going to be n minus 1. And so we're looking for 24. And so we can turn to the t-table, right? So in the case of the z, we're getting pretty familiar, and we can kind of rattle off 1.96 or 1.645 likely. But for the t, we're going to need to reference the table, and you can verify this, but you should be able to find now. A value. Actually, let's go ahead and see if I can pull that up, because we do need to figure out how to read this t-table a little bit differently. So remember when we first talked about t-tables, we were dealing with confidence intervals, and we said to kind of ignore this level of significance. Well, now we're ready to incorporate that. We are working with a one-tailed test. So there's two extra rows here, and it depends on if you're looking for a one or a two-tailed test. So we're going to focus on the one-tailed test, and we're looking for a 5% significance. Now, just as we're kind of glancing at the test or at the t-table, we'll notice that the two-tailed test is twice as large here. So you'll be in the same column if you are looking for a 10% two-tailed. But here we are in the 5% one-tailed test, and we can go down to alpha. Sorry, not alpha. Alpha is 0.05. We'll go down to degrees of freedom of 24, and we find the t-statistic of 1.711. And that is going to be our statistic. So 1.711. That's not the right button. There we go. And so we can plug in 1.711 as our t-statistic, and that is, and so in our process, in our situation here, that would be a negative 1.711. So if we find a t value of smaller than negative 1.711, we would have enough evidence to reject the null. Now again, notice because this is a one-sided test, we can get values out here. We could have a positive 2.5, and that wouldn't be in the rejection region. Just abbreviate that. Rejection region is only on this one side, because again, we're only focused on anything greater than 52,000 is not going to reject the null hypothesis, or not going to be evidence against the null hypothesis. In either case, the one-sided or the two-sided, really what we're after here for step 4 is to set up for step 5 and say, here are kind of our critical values. Here are the limits to which we won't have enough evidence. If we find something beyond these levels, we would then go ahead and reject the null hypothesis.